Welcome to Learning with UNP. In this session of Python for Data Science, we are going to understand about operators. That includes what is an operator, what are the types of operators, what are the arithmetic operators, and finally, what are assignment operators. Let us first look at what is an operator. Operators in Python are symbols that perform operations on one or more operands to produce a result. Operators refer to special symbols that perform operations on values and variables. Operands refer to the values on which operator operates. They are used to perform various tasks such as arithmetic operations, comparison operations, logical operations, assignment operations, and more. Now let us look at what each type of operator means. First comes arithmetic operators. Arithmetic operator perform mathematical operations like addition, subtraction, multiplication, division, exponentiation, and modulus. Second comes relational operators. Relational operators compare the values of operands and determine the relationship between them, such as equality, inequality, greater than, less than, etc. Third comes logical operators. Logical operators combine Boolean values or expressions and determine the logical relationship between them, such as and or not. Fourth comes assignment operators. Assignment operators assign values to the variables and perform operations simultaneously, such as addition assignment operator, subtraction assignment operator, multiplication assignment operator, etc. Next comes bitwise operators. Bitwise operators perform bitwise operations on binary representations of integers such as and, or, etc. Sixth comes membership operators. Membership operators check for the membership value in a sequence such as in and not in. Last comes identity operators. Identity operators check if two operands refer to the same object in memory such as is and is not. Operators are considered as the fundamental components of Python programming and are used extensively to manipulate data, make decisions, and control the flow of a program. Now, let's dive into understanding arithmetic operators clearly. Arithmetic operators are the symbols used in math to perform basic calculations like addition, subtraction, multiplication, and division. They help us manipulate numbers to solve problems or perform tasks. Arithmetic operators can be applied to various data types, including integers, floating point numbers, and complex numbers. Now, let's look at the pseudocode representation of it. Step 1. Decide on the arithmetic operation you want to perform. Means choose the math operation you want like addition, subtraction, multiplication, division, etc. Step 2. Write the expression using appropriate arithmetic operator. Plus for addition, minus for subtraction, etc. Means write the expressions using the right symbol. Step 3. Ensure operands are on both sides of the operator. Means make sure that you have numbers or variables on both sides of the symbol. Step 4. Optionally store the result in a variable for future use. Means if needed, save the result in a variable. Step 5. Execute the Python script to see the result of the arithmetic operation. Means run your Python code to see the answer. Here is a table depicting different arithmetic operators starting with addition, followed by subtraction, multiplication, division, quotient or floor division, modulus, and exponent. Let's now look at assignment operators. Assignment operators are used in programming to assign values to variables. They are shortcuts for performing arithmetic or bitwise operations and then assigning the result to the variable. The syntax for the simple assignment operator is variable is equal to value. Here, the value on the right side of the equal sign is assigned to the variable on the left hand side. Now, let us look at the pseudocode representation of it. Step 1. Choose a variable to assign a value to. Means choose a name for a storage location in your program. This name will represent a value that can change or be updated. Step 2. Decide on the value or expression you want to assign to the variable. Means decide on a specific value or calculation you want to associate with that variable. This could be a number, a word, or a result of a calculation. Step 3. Choose an assignment operator. Means select the appropriate assignment operator to indicate how you want to assign the value to the variable. The most common one is equal to, which simply assigns the value on the right to the variable on the left. Step 4. Write an assignment statement using the chosen operator. Means combine the chosen variable name, assignment operator, and the value or expression you want to assign. This creates a statement that tells the program to store the value in the variable. Step 5. Execute the Python script to assign the value to the variable. Means run your Python script to carry out the assignment statement. Python will execute the instructions assigning the specified value to the chosen variable. Let's look at what each assignment operator does. Assignment operator equals to assigns the value on the right side to the variable on the left side. Addition assignment operator adds the value on the right side to the variable on the left side. Subtraction assignment operator subtracts the value on the right side from the variable on the left side. Multiplication assignment operator multiplies the value on the right side with the variable on the left side. Division assignment operator divides the variable on the left side by the value on the right side. Floor division assignment operator performs floor division on the variable on the left side by the value of the right side. Modulus assignment operator computes the modulus of the variable on the left side with the value on the right side. These operators combine arithmetic or bitwise operations with assignment, allowing for concise and efficient code. Let's look at an example showing assignment operators. Initially, x is assigned to the value 5 and we print it. Let's execute it. And the output is 5. In here, we add 3 to the existing value of x, which is 5, and store the result back in x. Now, let's execute it, and the output is 8. In here, we subtract 2 from the current value of x, which is 8, and store the result back in x. Now, let's execute it, and the output is 6. Here, we multiply the current value of x, which is 6, by 4 and store the result back in x. Now, the output is 24. In here, we divide the current value of x, which is 24, by 2 and store the result back in x. Now, the output is 12.0. Here, we find the remainder when the current value of x, which is 12, is divided by 3 and store the result back in x. Let's execute this. Now x becomes 0. Since 12 is divided by 3, leaves no remainder. So the output is 0. Here, we raise the current value of x to the power of 3 and store the result back in x. Let's execute it. And the output is 0. It is because since any number raised to the power of 0 equals 1, x becomes 0 and we print it. Here, we perform floor division on the current value of x, which is 0, by 2 and store the result back in x. Since 0 divided by 2 results in 0, let's check with output. The output is 0 again. This is all about today's lecture. See you in the next lecture. Thank you.